This is a series of tutorials on building a straightforward online game using Microsoft SignalR and React. Welcome to the 5th video in the series. In the last video, we discussed how to create JWT tokens and refresh tokens. We also covered how to securely store these tokens in the SQL database upon user login. In this video, we'll delve into more advanced topics, including real-time token refreshing with the backend, refresh token validation, and the process of generating a new JWT token with each refresh. If you're just joining us, I highly recommend watching the earlier videos in this series to catch up. Before diving into today's coding, let me quickly recap what we accomplished in the last video. We successfully implemented JWT token creation and refresh token creation for users upon login. These tokens were securely saved in our SQL database. Now, let's jump into today's coding session. First, we'll incorporate global context into our React app. Let's navigate to the context folder, and within it, create a new TypeScript file named context.tsx. Inside the context file, let's create a global state component. Name the component as global state. This component will have a return type of React.fc. FC stands for Functional Component of React. Let's create a global context variable. Export a constant named global context and set it equal to create context. This create context function needs to be imported from React hooks. Since this is a TypeScript file, we need to specify the type. We'll start by using the anyType and pass an empty object as the default value. Next, return the global context provider from global state. This is a destructuring assignment of the children prop from the props object passed to the component. It extracts the children prop from the props object for easier use within the component. Let's modify this component to accept any type and then initialize the context values with empty strings as the initial state. Next, we need to provide this global state to the application. Inside the index.tsx file, let's wrap the app component inside the global state component. Then I will add the reducer file inside the context folder. This reducer file in a React app typically contains one or more reducer functions, which are responsible for managing state changes in response to dispatched actions. First, I will create the user control reducer function. This function will accept the current state and an action with a type of any. Initially, it will return the current state. Next, to create the interface for these states, I will create a new TypeScript file named as types.ts. For the user state, create a new interface called userState. To handle the user's login state, add a Boolean variable named isLogin. To store the username, include a string variable named username. Next, to manage actions, define an action interface. Within the action interface, add a string variable for the action type. Additionally, include a payload variable of type any to carry parameter values for user actions. Save the file, and let's integrate these interfaces into the reducer function. Now, we'll update the state type to userState and the action type to action. This change ensures that our reducer function properly handles the specific types defined in our interfaces. Let's move to the context.tsx file to integrate these changes. We start by defining initial user state, which sets isLogin to false and username to an empty string. Within create context and define the structure of our context, specifying that it will contain a user state of type userState. We pass the initial user state as the default value for user state. This context allows us to share the user state across different components in our application. Next, we extend our global context to include a dispatch function. We update the context to contain both user state and user dispatch. User dispatch is of type React.dispatch, pass type of action, which will allow us to dispatch actions to update the user state. Provide a default undefined function for user dispatch function type. Next, we have to define the global state component that provides user state and user dispatch to its children. Change the global context provider value to user state and user dispatch. This global state function accepts any type. Let's change it to type for the children prop. Add the global state props interface to define the type for the children prop. Type of React node. Add this interface to the component props. Integrated the use reducer hook to manage state within the global state component. Provide the user control reducer function and the initial user state. Change state to user state and dispatch to user dispatch. Save the files to apply these updates. Navigate to the login.tsx file to update the user state. Let's access the global context using the useContext hook. Here, we destructure isLogin and username from userState. and also get the user-dispatch function from the global context. After the user successfully logs in, we'll use the user-dispatch function to call the user-reducer function. This dispatch function will have the type a login, and the payload will carry the username, which is username input. Next, let's move to the reducer.tsx file to handle the user login state. Inside the user control reducer function, we use a switch statement to handle different action types. The default case returns the current state if the action type doesn't match any cases. And this user control reducer function return type will be the user state. Let's update that also. For the login action type, let's get the state and update the username to action.payload. Also change the isLogin to true. I realize that user state values are not required for login, so I will remove that. Let's move to the header.tsx file to update the user login case. We need to access the global state from the global context. Use the useContext hook to access the global context. Here, we destructure isLogin and username from user state. Inside the nav bar, we want to conditionally render items based on the user's login state. When the user is logged in, we don't want to display the login and register nav items. So cut the login and register nav items and paste them within a condition that checks if the user is not logged in. If the user is logged in, we add new nav items to display the username and a logout option. Add a new nav item that displays the username. Add another nav item for logout. Copy the styles from the login nav item and apply them here. Also, set the cursor to pointer for login item to change it to clickable item. When the user clicks logout, we need to handle this event. Within the onClick method, add a new handler for the logout case. Let's implement this logout handle function. We also need the user dispatch function from the global context. Get that also. Inside the logout handler function, call the user dispatch function with an action of type a logout and an empty payload. Move to the reducer.tsx file to add the case for logout. Add the case for logout. Get the state and change the isLogin to false and username to empty string. When user logout, we need to remove the JWT and refresh token from local storage. In header section, I will add new navbar brand tag to display the username when user logged in. Let's save all the files. Let's check the updates we have made. Open the login page in your application. Log in as a registered user. You can see that the user logged in successfully, but an error occurred. Username key object not valid. Let's check the code. After the user login is successful, I call the user dispatch function with a payload object containing the username property. Inside the user reducer function, I need to specify that the username property should be what is in the payload object. Let's save the file and check again. Log in again as a registered user. You can see that this time the user login is successful, and the username is displayed in the header section. Additionally, the tokens are saved inside the local storage. Now, let's log out the user. You can see that the username disappears from the header section, and the tokens are removed from local storage. Now, I will quickly log in as a different user. The login was successful, and the username is displayed in the header. You can see that all the functions are working as expected. In the navbar, the logout and username sections are not correctly styled. I will quickly change the style settings. It's just styles, so you can follow these steps. Now it's perfect. Let's move on to the other sections. After the user logs in, we need to continuously update the refresh token and the JWT. Let's implement that. I will create a function called check token expiration to verify if the token has expired. Before implementing the function, I would like to save the JWT and refresh tokens inside the user state. For that, I will go to the user state interface and add two properties, one for the access token and one for the refresh token, both of type string. Since we changed the user state, we need to update these properties in the initial user state to be empty strings. Let's move to the login.tsx file. After the user logs in, I will pass the access token and refresh token inside the payload property. Then, we can access these properties from the reducer function and update the global user state. Move to the reducer file to update the login case. We need to update the login case to handle the access token and refresh token passed in the payload properties. Now we can get the access token from action.payload.accessToken and the refresh token from action.payload.refreshToken. Let's continue with the check token expiration function. Only if there is an access token registered for the user state, it means the user is correctly logged in. So, if there is an access token, I will call the refresh token endpoint to refresh the tokens. Before that, I need a timer to refresh the token. For that, I will define a variable called refresh interval. Type of Node.js.timer. That can also be null when it's not defined. If this refresh interval is not defined, I will set a new interval with a callback function and an interval time of 10 seconds. Let's implement a new callback function called refreshToken. Pass this function to the setInterval callback. First, retrieve the JWT token from local storage and store it in the JWT token variable. Check if JWT token is not null. If the token exists, we proceed to decode and check its expiration time. Let's decode the JWT. Declare the function to decode JWT. This function takes a JWT string as input. JWTs are composed of 3 parts separated by dots: the header, the payload, and the signature. In this line, we split the token by the dot character and access the second part, which is the base64 URL encoded payload. We store this in the base64 URL variable. Replace certain characters in the base64 URL string to make it a valid base64 encoded string. Specifically, we replace the -a character with a plus and the underscore character with /. This is necessary because JWTs use base64 URL encoding, which is slightly different from standard base64 encoding. Let's check the JWT decoded values. Copy this JWT value. Paste it on some JWT token decoding online site. So you can see that decoded JWT token. Finally, we decode the base64 string. The atop function decodes a base64 encoded string, converting it back into a JSON string. Then, JSON.parse parses this JSON string into a JavaScript object, which we return from the function. The decoded token is stored in the decoded variable, which contains the token's payload, including the expiration time. We check if the token's expiration time, decoded.exp, converted from seconds to milliseconds, is greater than the current time. If the token has not expired, we proceed to refresh it. If the token is still valid, we call the new function called fetchRefreshToken to get a new refresh token. If the token has expired, dispatch a logout action to update the user state and log out the user. Let's implement fetchRefreshToken function. This is an asynchronous function. This function will handle the fetching of a new access token and refresh token from the server. Inside the try and catch, when there is an error, I will simply log the error. Retrieve the JWT token and the refresh token from local storage. These tokens are necessary for the refresh token request. Let's make a fetch request to the refresh token endpoint. Construct the URL for the refresh token endpoint using the environment variable. Method post specifies that we are making a post request to the endpoint. Headers specifies the headers for the request. Here, we set the content type to JSON. Body contains the data we want to send to the server. We stringify an object containing the access token and the refresh token. Then handle the response from the fetch request. Method to the fetch request to parse the response body as JSON. This returns a promise containing the parsed JSON data, which we store in the result variable. Save all the files. Let's move to the ASP.NET Web API application to implement the refresh token endpoint. Open the user controller file. Next, add a new HTTP post method for refresh. This post attribute name must match the URL we call in our React app. Let's add an asynchronous public function to handle this refresh endpoint. This function returns an iAction result and we will call it refresh. It accepts a token DTO from the request body. Check if token DTO is null. If the token data transfer object is null, return a bad request with a message indicating an invalid client request. If the token DTO is not null, extract the access token and refresh token from the DTO. Next, we need to validate these tokens. Let's implement the validation function. This private function returns a claims principal, and I will call this function getPrincipal from expired token. This will accept a JWT token as a parameter. Next, we need to get the token validation parameters. These should be the same as what we used when creating the JWT token. Let's copy those validation parameters and paste them here. We need a token handler to validate the token. Let's create a new JWT security token handler. This is the same handler we used when creating the JWT token. Also, we need a security token to store the encoded JWT token. Because the token validation function accepts an out parameter for the encoded token. Let's get the principal from the JWT token, using tokenHandler.validateToken. We pass the token validation parameters, and the variable to store the encoded security token. Let's cast this security token to a JWT security token. If the JWT security token is null, or the token algorithm does not match hash-based message authentication code SHA-256, we throw a security token exception. Next, we move on to the refresh function and call the getPrincipal from expired token function to get the principal from the JWT token. Pass the JWT token value. Let's get the username from the principal. This is the username we included when creating the JWT token. Next, let's search for this user in our database. If the user is null, or the user's refresh token does not match the provided refresh token, or the refresh token's expiry time has passed, we return a bad request with the message, invalid request. If the above conditions are not met, it means the JWT token is valid. So, let's create a new JWT token for this user. Also, create a new refresh token. Let's save these new tokens to the user. We need to set a new expiry time for the refresh token. Let's add 5 days from now. Don't forget to save both token and refresh token. Save these updates to the database. Finally, let's return the new token DTO with OK response. Access token equal to new access token, and refresh token equal to new refresh token. When I created the JWT token, I set the expiration time to 1 day. For demonstration purposes, I will change it to 10 seconds so we can see if the expiration is working properly. Update the expiration time in your token generation logic and save the file. And run the ASP.NET application to apply the new token expiration setting. Open your React application to test the updated JWT expiration and refresh functionality. In the context file, change the refresh interval to 9 seconds so we can ensure it refreshes before the JWT token expires. The fetch request to the refresh endpoint will return a result with new tokens. If the result contains the access token property, the request is successful. If there is an access token, I will store the new access token and refresh token in local storage. Call the user reducer to handle the token refresh. Type of refresh token and a payload carrying the new access token and refresh token. Move to the reducer file and add a new case for refresh token to update the state with the new tokens. Start the refresh token timer to fetch the refresh endpoint when the user login is successful. Use the useEffect React hook to watch for changes in the isLogin property of the user state. When the user logs in, isLogin becomes true. The checkTokenExpiration function is called to start checking the token expiration. The dependency array, userState.isLogin, ensures that this effect runs only when isLogin changes, preventing unnecessary calls to checkTokenExpiration function. This function will start the refresh token callback function every 9 seconds. Ensure to stop the interval when the user token expires. If the refresh interval exists and is not null, clear the interval. Save all the files and run the application to test the updates. Let's log in as a user to check the functions. You can see that the refresh token is working correctly. Every 9 seconds, it updates the tokens. Let me show you the JWT token. Copy the JWT token from local storage and paste it into a JWT decoding site. You can see that the difference between the creation and expiration times is 10 seconds. Let's move back to the app. You can see that the user has logged out and the tokens have been removed from storage. This happens because we set the refresh interval to 9 seconds and the token expiration time to 10 seconds. Sometimes, after a few requests, the token will expire before the callback. So that token expiration also works fine. Therefore, we need to set a proper expiration time and refresh interval time for correct refreshing. I will set the refresh callback interval to 100 seconds. Also, when creating the refresh token, I will add 1 day to the expiration time of the token. You can adjust these values as needed. In this video, we covered how to implement user login and token management in a React application. We created interfaces for the user state and actions, set up a global context and reducer to manage state changes, and implemented functions to refresh tokens and check for expiration. Additionally, we demonstrated how to handle token validation on the backend with an ASP.NET Web API. Finally, we ensured the proper intervals for refreshing tokens and validated the entire process by logging in and out of the application. In the next video, I will explain how to create a Tic Tac Toe game user interface using React with TypeScript. Additionally, in the upcoming videos of this series, I will cover how to handle online users with a database using Microsoft SignalR. Please stay tuned throughout this series to learn a lot. If you enjoy my content, please subscribe to the channel, like the video, and hit the notification bell. Thanks for watching.